Hi, I'm Masha Buddhini, the leader of this group, and I'm here with my talented teammates. Today we are going to talk about the valuable manufacturing process about tires. What is a tire? A tire is a circular and ring-like part of vehicle that comes in contact with the ground. And there are some extra introduction about tires and their backgrounds. And now I would like to show you some key life cycle stages about tire manufacturing. There are 5 main life cycle stages in here. They are raw material extraction stage, processing stage, packaging and distribution stage, use and maintenance stage, and end of life stage. The raw material extraction stage is the main top process in this manufacturing system. So in here we have two sub-processes. They are sourcing raw materials and material preparing. So we use natural rubber, synthetic rubber, carbon black, steels, chemical compounds and fabric coats as main raw materials in this stage. And this processing stage can be classified under several steps. There are steps like mixing, underground processing, assembly of compounds, and quality control, inspection, and something like that. And when we talk about package and distribution stage, the finished tires are packed according to their sizes and their type, and also ready to shipping. And when we talk about use and maintenance stage, once the tires are in the hand of consumers, they enter the use and maintenance parts. And the final stage is end of life stage. It's a stage that involves the disposal and recycling process. Then I would like to show you some lengths of life cycle stages. There are 4 main lengths in here. They are cradle, cradle to gate, and gate to grave, and grave. We can put source in raw materials, material preparation, extraction, underground processing, and mixing parts in cradle stage. And we can also put assembling, quality control, curing, inspection, trimming, finishing, packaging, distribution, and something like that in cradle to gate stage. And in gate to grave stage, we can put transportation and use and maintenance parts. And in grave stage, we can put end of life cycle stage. And finally, I would like to tell you that what are the stakeholders in tire manufacturing process. There are so many stakeholders in here. They play different roles in tire manufacturing process. As examples, when we talk about raw material suppliers, they help to source in raw materials and also help to control quality. And as tire manufacturers, they design a tire and they select the raw materials and also involve the manufacturing process. And as engineers, they play essential roles in different aspects of the production process. And in addition, we can get natural rubber plantations, quality inspectors, laboratory technicians, production workers, production managers, and distributors and wholesalers, and all the people that you can see in this scheme as stakeholders in tire manufacturing process.
Now let's turn our attention to the tire manufacturing process flowchart. Today we delve into a complex world of tire manufacturing, a process that transforms raw materials into essential rubber donuts that keep us on the road. Beyond the black donuts we see there's a complex series of steps that turn inputs into outputs, all fine-tuned for performance, safety, and sustainability. I will walk you through the tire manufacturing process flowchart and categorize the inputs and outputs into renewable and non-renewable resources. First, raw materials must be procured. Rubber, steel, chemicals, and textiles are used as raw materials. Then there is a preparation step. The raw materials are mixed as required and wheat and built steel cord manufacturing is done here. Then the tire components step. Calendering and bias cutting are done in this step. After that is the finishing step. Building, curing, and final inspections are done here. Finally, the finished tires are packed and distributed, but it is not the end of sustainable production. Therefore, end-of-life tires should be collected, recycled, and used again for a tire production.
When making tires, they first decide on rubber mix. Then they mix it well in a big machine with spinning parts. This machine breaks down the rubber, fillers, and chemicals to make a mix. They are careful about how hot it gets during mixing. They do it in stages to keep the mix safe. After mixing, they get long pieces like sheets called a slab. They press this sheets with rubber onto strong threads made of fabric or steel. This sticking together is really important for how the tire works. They use a special machine with spinning metals rods to do this. Finally, they cut the sheets into the right space for the tire. So making tire means getting a mix right there, sticking things together well to make a strong and good tire. In making tires, the bead holds the tire onto the wheel. It's like a strong loop made a rubber covered steel. There's also a hard rubber part and sun protectors. Getting the size right is important. The part that touches the rod is called the tread. It has different parts, the main tread, the side and the bottom. They use rubber that pushed into shapes like making dough into cookies. The sides of the tire are made the same way. Inside there's a super thin layer that keeps the air in. It's made from a special rubber and helps the tire stay strong. Making tire is like a making puzzle, using the right parts and making sure everything fits just right for safe ride. Once all the parts are ready, the high-tech robotized machine takes over the building tire with precision and efficiency. This process brings together everything the brake, tire, belts, inner liner, tread and sidewall section. For a radial tire, it's a two-step process on a flat drum. First, the inner liner wraps around the drum, followed by body, wheels and bead assemblies. Then the drum inflects, making a piece turn up and cover the bead. Sidewall section are added next. In the second step, other machine add beads, a nylon cap and the tread, but the tires isn't done yet. It needs curing because the tread pattern isn't there. This stage is essential for the final strength and shape of the tire. In the last part, called curing, a special chemical reaction happen. The sidewalls and tread get shaped too. This is like baking a cake, but with chemical. The tire goes into a mold where it is heated and pressed. The hot rubber flows into the mold, making the tread and sidewalls. The mold stays closed until the chemical magic is done. This step makes the tire strong and final. In the final step, which is inspection, they make sure the tire is perfect for the road. They do many checks like trimming extra bits, looking closely for any problems, and even using X-ray to see inside. They also test how strong and balanced it is. Only when it passes all these tests, the tire is ready to hit the road and keep us safe and moving. Now let's talk about inputs and outputs. From this table, you can identify the inputs and outputs related to the steps. Here you can study about renewability and non-renewability in inputs and outputs. In particular, we cannot see renewable outputs here.
I like to talk about a crucial aspect of sustainability and environmental impact, comparing the performances of products using functional units. Functional units provide us with a standardized way to measure and compare the environmental footprints of similar products. To illustrate this, I'll be discussing the production of vehicle tires and rubber sheets using three distinct functional units: production, quantity, driven kilometers, and years of usage. Let's dive right in by exploring the functional units we'll be using for comparison. Our first functional unit centers around the production of 1 ton of vehicle tires. This is a standard measure that allows us to assess the environmental impact of tire manufacturing. You will see in next slide that energy consumption during tire production stands at 753.93 kilowatt hour per ton. Furthermore, water consumption varies across different stages of production. From rubber compounding to curing and cleaning, these values provides us with a baseline to compare tire production's resource usage and environmental impact. The second functional unit will compare is driven kilometers. By measuring the environmental impact per kilometer driven, we get insights into a product's contribution, pollution, and resource consumption during its usage phase. This is particularly relevant for vehicle tires as they directly interact with the road surface and impact fuel efficiency, emissions, and overall vehicle performance. The third official unit, years of usage, extends the assessment of environmental impact over a product's entire life cycle. This perspective allows us to understand how materials and manufacturing choices influence long term sustainability. When we talk about the years of usage, we consider the durability, maintenance requirements, and overall life cycle impact of the product. Let's compare the environmental performances of tire manufacturing and rubber sheet manufacturing using the functional units we discussed. Here, we compare the environmental impact of tire manufacturing and rubber sheet manufacturing. As you can see, energy consumption for producing 1 ton of vehicle tires is 753.93 kilowatt hours. Water consumption varies across stages such as rubber compounding, calendering, curing, and cleaning. Greenhouse gas emissions include carbon dioxide, nitrogen dioxide, and sulfur dioxide. For rubber sheet manufacturing, energy consumption for producing 1 ton of rubber sheets is 200.45 kilowatt hours. Similar to tire manufacturing, water consumption varies across different stages. Greenhouse gas emissions include carbon dioxide, nitrogen dioxide, and sulfur dioxide. We are diving into the essential aspects of tire maintenance from mounting to regular upkeep. I'll guide you through the entire life cycle of a tire, highlighting its installation, in-service use, regular maintenance, rotation, balancing, and repair. Our journey begins with the meticulous process of mounting a new tire onto a rim. With specialized equipment and skilled labor, we ensure a secure fit. The result? A perfectly mounted and balanced tire ready for seamless installation onto your vehicle. This fundamental step sets the stage for an optimal driving experience. Once on the road, the inputs change. Your vehicle, the road surface, and your actions as a driver all influence how the tire performs. Traction, stability, shock absorption, these factors impact your safety and comfort. The tire's design shines as it adapts to different conditions, leaving its mark on the road while minimizing wear and tear. Regular maintenance is the key to sustained performance. Through visual inspection and careful monitoring with a tire pressure gauge, we ensure that your tires maintain proper inflation. This not only enhances safety but also extends the tire's lifespan. Tire rotation enters the spotlight, addressing the uneven tread wear that can occur. Using a jack and jack stands, we lift the vehicle and rotate the tires. This simple procedure evens out wear, ultimately extending the life of the tire and enhancing overall handling. It's a small step that yields significant benefits. Imbalance can lead to vibration and reduce performance. Our balancing process employs specialized equipment and small ways to ensure even rotation. This results in a perfectly balanced tire that contributes to a smoother ride, improved handling, and reduced vibration. Even in the best care, punctures can happen. That's where tire repair comes in. With the right tools and materials, our skilled technicians patch up the tire, restoring its functionality. This approach not only saves you money but also minimizes waste by keeping the tire in service.
In end of first life use stage, we can put grown out tires in shallow treads as inputs, and the tires that ready for reuse can be used as outputs. And in reuse and recycling use stage, we can put used tire casings, retreaded materials, and recycling machinery as inputs. And the reused tires and recycled rubber materials can be used as outputs. And in the second life for recycling applications use stage, we can use recycled rubber granules, manufacturing equipments as inputs, and recycled rubber products such as rubberized asphalt can be used as outputs. Finally, We should manufacture tires by prioritizing eco-friendly materials, optimizing production processes, and fostering innovations. By doing that, we can have the opportunity to drastically reduce our ecological footprints and also make a path for green future in sustainability. Embracing renewable energy sources and efficient recycling systems and responsible sourcing will propel us toward the circular economy and a healthier planets. So, as we steer this industry toward greater sustainability, we not only ensure better products but also contribute to a brighter future for both our environment and generation to come. Thank you.